should also be able to check out the live stream on YouTube right now. And then let's start. So I'll start off with, hello, thanks for joining everyone. Today we'll give a presentation about the new Pixi Global. This will not be a speaker from another company, but we'll do it ourselves this time. And me and Julian will present it. Julian will do the first part and I will do the demo on my machine. I'm currently streaming from a different machine that I'm presenting from, so if there's any weird stuff, please let me know by talking into the microphone, because I can hear that. And yeah, hope you enjoy it. Julian, it's your go.
Yeah, thanks, Ruben. I'm actually pretty excited about all of that, because you, Ruben, Nikita, and I, we invested now quite a bit of time into that. Next slide. But before one more even. But before we go into all of these exciting new things of Pixi Global, one thing that I also want to highlight just how awesome the current Pixi Global is. So as a reminder for people who don't know, we already have a subcommand global, which allows you to install command line applications globally on your system. And why we think it's really cool is because it's one of those few package managers, maybe even the only one, who, for one, works cross-platform. Because if you use your distribution, if you use Debian and install your package with apt, you cannot tell your colleague using a different Linux distribution, or maybe even a Mac, to use the same command to install the same package, which makes it really hard to share the same command line applications with your colleagues. And even if you go through that barrier, if you say, well, we just use pip for all of that, the situation that you then face is that, well, pip 99% only works for Python packages. So what you then end up with that you need multiple package managers for each language. And this problem you just don't have with the Conda ecosystem at all. You can use Pixi Global install to install your packages on Mac. You can install them on Windows. You use the same command on Linux. As Wolf recently highlighted, you can even do it with WebAssembly. And it works for Python, it works for C dependencies, it works for Rust. Basically everything you can find on the Conda channel of your choice. And all of those things, like cross-platform, cross-language, you already could do with Conda itself. Because if you have Conda, you have a base environment, you can just install everything into it. If some of you did that, you probably know that it doesn't really work well in practice. At some point, something will break, and even if it doesn't, what you will find out is that you have no idea anymore what you installed in the first place. When we talk about sharing stuff with your colleagues, having a similar tool chain, that just makes that basically impossible. So one thing that the current Pixi Global already did is to isolate all of these tools. If you install one specific command line application, it will install it in one environment. If you install a second one, it will install it in a second one, and it will only expose the command line entry point. That way, those will not conflict. If you have one command line application with conflicting dependencies to a second one, it's not a problem because they're separate environments. And last but not least, Pixi is fast, and so is Pixi Global. So everything just works smoothly. So I really like using Pixi Global as it already is. Next slide. But there were still a couple of things which we didn't like too much. Again, the use case of having a synchronized command line applications across a team or even friends. It's still not super obvious what you have installed or how you installed it. There's not like one document which you can give to someone else and say, well, just use that, and then you have the same thing as I do. But with the new Pixi Global, you do. Every single time you run one Pixi Global command, it will write that down, it will note it into a manifest, a readable as well as writable manifest. And you can just take that, put it into version control, give it to someone else, back it up. If something happens with your environment, if you want to set up a second PC, you take the manifest and you will have exactly the same thing. The second thing that we had with Pixi Global is that while it's really nice that you have isolated environments, you, by default at least, sometimes you want to opt out of that, in the sense of if I want to have, maybe I want to have a separate environment for RibCrep and IPython, but maybe I want to share some things in one environment. For example, IPython is much more useful if you have Python packages with it. I want to add SciPy polars to the environment where IPython is in order to access it. And that wasn't possible with the current one, but it is with the new pixi global. And last but not least, sometimes you want to have multiple versions of the same package. And distribution solved it by just prefixing it. Like, for example, you can, certain packages, you can install multiple versions and then they just add a number to it. But it doesn't work in general. But we now give you the option to just rename your executable with whatever name you want. If you want to manage multiple Node.js versions, multiple NPM, as Ruben will highlight or showcase later on, you can just do that. You can have one Node.js environment of version 20, second one of 21, a third one of 22, and expose for the first one npm 21, the second one npm 22, and the third one npm 22, 20, 21, 22. And none of them will conflict because you give it a separate name, and only that will be exposed on the outside. Next slide. And one thing that was really important to us is that even though we added all of these really useful capabilities, the most basic use case doesn't require you to think about them at all. Because in the most basic use case, you don't think about environments, at least I wouldn't. All you want is, I have a certain executable, it is called IPython, and I want to install it and I want it globally available. So you run pixi global install IPython, and exactly that happens. Afterwards, IPython will just be available. Behind the scene, however, what it will do is it will create an environment called IPython, installs a package called IPython, and exposes the executable IPython with the name IPython, and a second executable IPython3 with the name IPython3. And you can use that complexity that happens behind the scene in the default case to also fulfill more complicated use cases. Like if we go through the second one, if we maybe move the mouse, Ruben, pixi global install allows you to specify the environment. And the most basic use case, that just means behind the scenes there's a different name. So it doesn't use IPython, the default your package name, it just calls it now science. Because we already have IPython, we can expose it as SciPython. Now you have two executables, one called IPython, one called SciPython. And because we specified an environment, it will now install both of these packages, IPython and SciPy, into the same environment. If we then try out SciPython afterwards, we will notice that for once, well, it's called actually SciPython, but it also has access to the SciPy package. And it's very easy to extend it afterwards. Next slide. And these two commands that we saw before, they will result into, at least in my opinion, a really readable manifest. We version it, we give it a 1 at the moment in order to allow us to break compatibility if we want in the future. And if we look at the first environment, it's much more complex, but it still shows what is happening behind the scenes. So Ruben, if you move your mouse to the first table, you see that the environment is called IPython. It has a certain channel. For one, it allows you to specify that, a conda channel. If you don't specify it, it will use your pixi config. And if you don't have that one set, it will use conda-forge. It will specify all the top-level dependencies that you have. And in the default case with pixi global install, it will expose all of them that you mentioned. So IPython has two executables and will expose them with the same name. IPython equals IPython, IPython3 equals IPython3. If IPython would have had transitive dependencies, so dependencies of dependencies, pixi global will not expose them by default. The second environment actually has exactly the content that you specified. So it has a different name, it's called science. It has two dependencies within the same environment. and it exposes CyPython. It exposes the name CyPython, but inside the environment it's called IPython. You can modify that. You can add something to it. You can then run pixi global sync, and your environment will then look the same way as is specified in the tumble. You can put into version control, give it to a colleague. All of that will work across platforms and across languages. And enough with the talk. Ruben will now give a nice live demo.
Thank you, Julian. That was a really good introduction to the new feature. I will turn off the presentation for now and go to the terminal that I've set up. And I'll quickly show you in practice what the example that we just told you about actually behaves like. So if I do pixi global install IPython, typo. Install IPython, I will start to install it like normal. It will tell me which version of IPython I've installed and which executables I can run. So if I now do IPython, I can actually start up an IPython interpreter, and that's just how you would expect it. So I really want to leave, yes. But if I do global install environment, I did try this all before, so that's why it will already expose it for me. And you can see I added the science, I exposed CyPython as IPython, and the two packages that I want in my environment. It will create the environment for me and tell me that CyPython is exposed. So if I do CyPython import, not polars because we don't have that, but we do have SciPy, that will just work. And it's not it doesn't give an error because it worked. Then what can we do next? We can show you what that looks like in the manifest. So if I do pixi global edit, it will open the editor my choice. And in this case, on my Windows machine, that's Notepad. And it will show you that I have added these two environments. Previously, I already had two environments to install Vim and Starship, but now you will see that those two environments are added. What I did do before this presentation, I also added our fast prefix channel, which means that the installations will just be a lot faster than a normal Conda Forge installation. But that's an artifact of my local machine and not part of pixi global by default. Then what we can do is we could possibly add another expose to CyPython. So for instance, I could say just a super simple spy equals IPython, and that will now also expose SciPy as the IPython executable. I need to save this file, I can close it then, and do a pixi global sync. Sorry for that noise in my mouth. And what will happen is it will check all the environments and if they're up to date with the manifest. And in this case, all my other environments were not changed, so they were still up to date. But the science environment had an executable added, and it will tell me that. So now if I do spy, I will also have that as an executable in my environment. Closing that again. And what can we do more? So what you will now not know is what is all installed on your system. So I can do global list. It will show me exactly what's installed on my system. It is simplified as much as it can. So IPython exposes two binaries, so it will show you that. It will show the version of IPython that is installed. But in a minimal version, for instance, Starship is a good example of that. It only exposes Starship. It only has the dependency Starship, so it will minimize it to only one line. For Science, which is a more complex environment, it will give me which dependencies are installed and how things are exposed. So this is a nice way of inspecting what your installation is actually doing. Then what often people use in the data science is polars. So let's start adding polars to my science environment. Pixi global add, I will do the environment science and the package polars. This will install also polars into that environment, and I will be able to do short version py -c import polars. And it doesn't do a lot if you run it like this, but it at least didn't error, and that's what I'm showing. Then there's this special case of having the multiple versions of a single binary. For instance, Node. That's the example I'm going to use. So pixi global again, install environment node. And in this case, I will name the environment with the version of the node I'm going to install. So that's going to be node 20. I'm going to expose node as node 20, and the only package that I want is node.js at version 20 something. I will install that environment. It will result in what I asked him for. And if I then do node 20 version, it will tell me which version of node I have. And this way, if I type node 20, it will just run node that's on my system, but specifically from that environment. I can do that again, but then for 22, do have to make sure I also the other exposed, change the other names. And now I also can do node 22 -- version. So let's do another pixi global. And you can see that these two environments are added. They have some special dependencies, so you will see that. And the rest kept to be exactly the same as before. Now let's also do the default behavior, because you've all seen this new extra stuff, but I can still do a pixi global install of multiple things. So maybe I want pod, maybe I want rip, grab, or one of our own tools, Rattler build, and that will still install them, tell you what has been installed, and also update the manifest. So I can do pixi global edit again, and you will see that all these environments are nicely added to my environment, and this way I will be able to share it with anyone or upload it to my dot files if I want to share that between machines. So I can have similar global environments on all my machines. So it would be as simple as just git init, and then this can be added. So, oh, sorry, that of course has to be in the .pixi folder. And you can see that there's the binary folder, the environments folder, and the manifest. And in the manifests, you will have that one toml that you would need to add to Git. This is the general demo. If there's any questions, please shoot and I can still show you. And if there's no questions, then we can go back to the presentation.
I have a question.
Please go ahead.
Yeah, so this effectively becomes like a homebrew, but it works for Windows as well, right? Or a home manager, which when you're using Nix. Is that right?
Yeah, so it's very similar to the two things you mentioned. The special thing here is that we do make virtual environments per package you install if you don't define them in the same environment. So dependencies will only be shared if you define it like that. But that also makes it a lot more trustworthy, because you cannot break one of your tools by breaking one of the environments in your global setup. And yes, indeed, you can now start pixi global installing Vim if you want, or even, install Vim. Git can also be installed. Yeah, you name it, it's on CondaForge already. And we already hope to improve that with our Rattler build tool, which is going to replace Conda build to make package building even a lot faster and easier as well.
Okay, thank you.
I already did it.
But yes, the first approximation, it's like homebrew, which also supports Windows.
Yeah, thank you very much. How do you update these packages? For example, a new version of Git releases upstream. Is there an update subcommand?
Yes, pixi global update will update all the environments, and if I want to update one specific version, I can just do git, and then it will update only that package. But I believe I just broke my manifest. Yeah, quickly. So that doesn't work right now because I didn't install it, but maybe if I do Vim then it will start reinstalling it to the latest version, which matches the version that I have in my manifest. But without specifying a version, you will automatically get the latest version.
Nice. Thank you very much. Really nice feature.
Thank you. We're very excited. Any other questions? Otherwise, I can go back to the presentation and there will still be some questions available afterwards. So how do you try it today? It's currently still in a release candidate version, so you can specify that with pixi self-update or the curl command and specify this release candidate for 33, and you'll be able to run it yourself. Please tell us anything that comes up if you try it out. We keep it in release candidate so we can still have some breaking changes in the format, for instance, if we really need that. And then in the next big release, we'll hopefully have it ready for everyone. But please test it out for us, and then we can quickly fix that without hurting anyone that didn't want this feature yet. So in conclusion, we just added even more awesomeness to Pixi Global. It was already pretty helpful for a lot of cases, but now it becomes much more flexible. You can now share your manifests, so your setups become a lot easier, either with colleagues or friends or with yourself on different machines. For instance, I use both Windows and Linux, so I can now share it between those to have similar tools. And you can have multiple dependencies in a single environment, which really amplifies the use cases of, for instance, IPython for a lot of users, or a pretty good example is having keyring with a lot of dependencies as plugins. For instance, specifically for Google Cloud or for AWS, you can now add those dependencies into that keyring environment, and then keyring can do what it is expected from it without breaking all the other environments around you. So we have some questions for you. Does this cover the use cases you were thinking of when you thought about a new Pixi Global? And which use cases do you have yourself that we can share around? Like, it would be awesome to see some use of this and understand what our users are trying to accomplish with Pixi Global. And I believe if there's no direct questions, then I want to say thank you. And I hope to see you in this show and tell anytime that we do them. And thank you for listening. If there's any more questions, please shoot.
Or use cases.
Or use cases. This is still open for input.
I have a question.
Please.
I am switching from Conda, and
Right.
to make things work with Pixi, I have a daily driver project directory, which is where I put things that I would have put in my environment I typically activate. I never use the base environment, I guess, but I would activate this is the same environment every day and do most of my workaday development. How do you think about when to use the project directory approach like I'm using now versus having a global IPython with a whole bunch of data science in it? How should I think about when to reach for each one?
Yeah, it's a good question. And it's definitely something that is not completely similar to how Conda works. But I would personally always say, like, use a project when you want to be able to make it easy to share, when you want to be able to be folder specific. It has a log file. It's much more compatible with how Git works, and there's a lot more features in there. So the projects are kind of the beasts here, and Pixi Global is just an add-on to Pixi to also support this feature set. But if you want to have a single environment that you use every day and that you just activate anyway, then I would say you can use Pixi Global perfectly for that. If it just is a set of dependencies that you want to expose to your terminal, specifically because you don't have to activate them anymore, and there's not a problem of the base environment where you automatically install into that and then create a whole mess for yourself. This is a little bit harder through the global command, and yeah, you can't just break your setup suddenly, because those exposed binaries will still work for you.
That you said something that made me wonder, does Pixi Global not have a lock file?
No,
So
it doesn't.
currently it doesn't. No.
Interesting.
So
because
maybe to elaborate a bit on that. So we are looking into having something equivalent, like a Pixi Global environment feature, which would sort of feature projects which will also have a log file. So for your specific use case, you would think, how do I see this environment, or these multiple environments? Are those kitchen sinks environment where mostly I have pandas, I have polars available, but do I really care about reproducibility, contained tasks? Then something like a globally available manifest would be more useful to you. If you're really happy with the kind of workflow, just want it to be fast and not break anymore, then I think the current new Pixi Global, the new Pixi Global install will be really useful to you.
That makes sense. Thanks.
Yeah, I have a use case to share. I work mainly on multiple HPC servers. Like I have access to many machines across the world where I log in and connect and do some science on each of them. So what I would like is like my common tools like BAT and ripgrep and FD and all these replacement like core utils replacements to be available everywhere, just because I'm so used to it. So that is my use case. And so for that, I was just wondering, are these binaries that get installed, are these relocatable binaries? Do they mind any prefix? Like, can I install it to any prefix?
Yes.
Yeah.
That's a perfect use case actually, but also yes, Conda environments are generally include relocatable binaries. The way we install global binaries is a little different, which I can show you, because in the bin folder in the Pixi directory, you will see these bot files, and they will activate that environment and run the tool in there. We're still looking into improving this, but yeah, currently that is not an exact binary. It's linking to a binary through a script. And on Linux, something similar happens, but that has to be platform specific, done by Pixi. You don't have to deal with this yourself.
I see. Okay. And these are reproducible builds. Like, so I get, I know what exactly is the provenance of each build. Like SPAC, like what SPAC does?
Yeah, so reproducible in the sense of reproducible if you specify the top level dependencies, if you specify the versions. As far as you specify them, that much they will be reproducible, but they're not reproducible in the sense of a Pixi manifest, because there's a log file. Your transitive dependencies will not be locked.
I see. Okay. So will you know what are the sources? For example, if I build an application, what are what are the versions of, like, what Perl version was used to build a specific thing? Like what MPI version was used to build? Is there like a complete provenance that that can be accessed somehow?
I think what you're questioning is a little bit more about the build process of Conda packages. Maybe Wolf can give some more input on that, because that's not per se global specific.
Yeah, so Spec and Conda have one relatively large difference in how they currently think about basically where the package comes from. And Spec, I think, more often built from source, where Conda packages are usually binary packages. And so if you consume Conda packages that come from Conda Forge, then you sort of have like they are always built in CI pipelines essentially, and you can look at the logs for up to 2 years after they've been built. And with the new tooling that we're building with Rattler Build, we also record exactly what packages were used at build time into the package itself. So we render that out, and then you can like look at it. And that's a little bit like an SBOM or something like this. So yeah, like we're definitely moving into that direction.
Okay,
And
thank you. Yeah.
if you want to have source builds, that's also something that we're currently building, which is a feature that we're calling pixi build. And hopefully we can talk about that more in 2 to 4 weeks.
Oh, very nice. Very nice. Thank you very much.
Yeah.
Thank you for the question. Anyone else?
For Rattler build, have you compared it to binarybuilder.jl, which is a Julia package? I think
Yeah.
it's also like a reproducible builder. In fact, one of my colleagues is the one who's developing it yeah, his name is Mose Giordano. So he's the one who.
Please put us in contact. So I know about Binary Builder and that it has definitely been a bit of an inspiration. I think it's a little bit sad that Binary Builder is very geared towards the Julia ecosystem, while actually doing something generic. And what we're trying to do is building something really generic that would work for, like that could potentially also work for the Binary Builder use case. I think one difference between Binary Builder and what we're doing is that Binary Builder always starts with a Docker container, which is really nice because it makes it relatively straightforward. Like once you have that Docker thing configured, makes it pretty straightforward to do cross compilation and stuff like this. And we can do also cross compilation, but we put together the environments basically from packages instead of using a Docker container as our like base building environment. And yeah, so I think that's the biggest differences. But yeah,
Okay.
like would love to talk more with these guys and sort of figure out what we can do to.
It's the next chair, so I'll be very happy. I mean,
Okay.
recently I've been talking about building something equivalent to what pixi has been doing. So maybe it's better to just join forces rather than doing something differently with the Julia ecosystem.
For sure.
Always. It's always better. Thank you.
Thank you.
Is there any more questions? If you don't want to talk out loud, you can also ask it in the chat. And if there's not, then I want to thank everyone for joining and hope to see you next time.
Thank you.
Thank you.
Bye-bye.
Thanks. Super cool work.
Thanks.